All right, class.
Yes.
Okay, that's not too bad. Not too bad. Okay. Huh? You want to try it again? You want to try it again? Okay. All right. Class.
Yes.
Okay, that one is better. Good job. All right, so 5.5 double angle identities. Now, a double angle is just twice whatever angle I have. What's double 30? So finding the angle of 60, I would just use 30 twice in one of my formulas. Okay? And they have formulas for each one, but a double angle is not the same as a single angle. And so that's going to be part of the homework, is identifying. Okay, so watch. Blah, blah, blah. Blah, blah, blah. Blah, 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 blah. Wah, 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 wah. Okay, here it is. These are the slides that we want to look at. These have my formulas on them. The formulas are super important. Okay, they're super important. If you notice right here, cosine says cosine of a double angle of 2a. Now, on your reference sheet also, which is also somewhere in front of you, this says 2a, but some of you have a reference sheet that says 2t or 2x. Okay, so find that on your reference sheet right now, please. It is, flip it over. There we go. Top left. So, does it say, it says double angle identities, right? So, your variable on a lot of your guys actually says t, right? So, it's 2t or 2x or 2s or 2a or 2 theta. Remember, that just represents my variable that we're talking about. Is anyone having trouble finding it? Yeah? Okay. Now, there's 3 of them for cosine. We have this one also, and this one here. Because cosine is going to be the key to all this stuff. We have 3 different ones, and so it depends on the information that's going to be given to you. So if we know x, y, and r, if we know all those 3 things, you can do all this easy. Okay? All the work beforehand is finding x, y, and r. And then you just plug into all these formulas that we have. So this one right here, this first one of cosine 2a here, is used when I know sine and cosine. So if I know the x and the y, right? X, y, and r. I have to know all of them to get that. The next one is going to be cosine, right? It only has a cosine, doesn't it? So I would use that one when I know the x value. But I don't know the y value, right? So I would use that one when I know the x value. Over here, this one is sine. So I would use that one only when I have the sine value, the y value, right? And I don't know the x, but if I knew the sine, I could use that to plug in for this. Does that make sense or nonsense? Kinda? Okay, it's going to make more sense when we start plugging stuff in. Sine, there's only one of these, right? There's only one way to plug that in. Okay, there's only one way to plug that in. And then tangent only has one also. But if we know x, y, and r, these are pretty easy to do. Okay, they're easy to do. See this right here? That is a single angle because it's just theta by itself. It doesn't say 2 theta. 2 theta would imply it's a double angle. But this is just theta, so it's a single angle, so that means I'm using x, y, and r. I just have x, y, and r. So what do we know cosine represents? X over r, right? X over r. So my x value here is, my y value is, I don't know yet, and my r is 5, right? So in a single angle, which we've been dealing with, I'm going to do x, y, and r. Is there a way to find the y value knowing the other 2? Mm-hmm. Pythagorean Theorem, right? So it's going to be x squared plus y squared, r squared. So it's going to be 3 squared plus y squared, 5 squared. 9 plus y squared is 25. Subtract 9 from both sides. I get y squared is equal to 16. Yes? Okay, we've done this same problem a whole bunch of times, so forgive me if I'm going a little bit faster on this, because we've done 3, 4, and 5 a bunch of times. So now right here, so how do I undo a square? Square root. When I square root, what can I not forget? Very good. So it's going to be y equals plus or minus the square root of 16, right? But what is the square root of 16? 4. So I know it's going to be plus or minus 4. But now let's go over here. This little piece of information is going to tell me what I need to know. It says sine. We know sine is which value? The y value, right? Sine is less than 0. So what numbers are less than 0? Negative. So what does that tell me about my y value over here? So I'm going to be -4. Very good. So -4. So that is all the main work I do to try and get to this. So now for the rest, I just need to start plugging in values. That's all I'm going to do, is just plug in values for the rest. So on this page right here, I will do this one. So we're going to bring that down because my formula says sine 2 theta. Sine 2 theta, right? Now the formula for that says 2 sine theta cosine theta, right? It's on the reference sheet. It's on your notes. If you want to highlight, you're going to keep having to come back to this over and over and over again. You guys agree? Hopefully? Okay, so now if you look at each of these thetas, there isn't a 2 in front of it. So these are single angles, so that means that they use x, y, and r. So let's bring it down. Bring down the 2. And the 2 is a whole number. It's a whole number, isn't it? So I could write that as a fraction as 2 over 1. Yeah, very good. 2 over 1. Because I'm going to multiply fractions here. And that's one thing I want to try and focus on and make sure I keep them all in the same spot, the right spot here. So over here, sine theta. So sine is going to be what over what? Y over r, which I have -4 over. Very good. And then my next one's going to be cosine theta. So cosine in this case is 3 over 5. Very good. Anyone questions? No questions? We're just plugging in. So now we multiply fractions. We multiply these straight across, right? We're going to multiply straight across. So 2 times -4, -8 times 3, -24, right? Over 1 times 5 times 5. And guess what? That's my answer. See that? I circled the answer. So that must be it.
So this one is easier than the one from yesterday? Or just less work? Yeah. So like you don't have to add.
Yeah, I guess. We've done X, Y, and R a lot. Every unit we've been doing X, Y, and R, haven't we? So we're just doing different things with X, Y, and R every time.
So each problem could be longer or shorter?
Yeah.
Depends on what the problem is?
Yeah, it depends on what's given to you. So this one right here, a single angle is given to you. So single angle has X, Y, and R. Double angles do not. And that's going to be part of example 2 that I'm going to come to in a moment, okay? So the next thing that we're doing is going to be this one. So cosine 2 theta. Because we're finding all 3 of these.
Oh. Yeah, that was the answer.
But wait, there's more. Now, there's 3 different formulas I could use, right? 3 different double angles for cosine. So I know X, Y, and R, so let's use that one. So that's going to be the first double angle, right? So that's going to say it's going to be cosine squared theta minus sine squared theta, right? Yes. So since I know all 3 of those, I might as well just use them. And it makes life a little bit easier when I do the math. So cosine. When I'm plugging in cosine, I put in parentheses. So what did we say cosine was? 3 or 5.
Wait, I have a question.
I have an answer.
I think. How did you know we had to use that formula?
You could use any of them. You could use. So if you look at the previous one, look at here, right here. I'm using this one.
Right.
I know what x, y, and r is, right? Say yes,
Yeah.
because that's what we solve for.
Oh, yeah.
See this right here?
That's defined.
If you only know the x and r, you would use this. Because sine is not there, right? There's no sine, and sine is my y value, isn't it? So I would use this if I only had the x and r.
Yeah.
And this one over here, I would use this one if I only knew the y and r, okay? And I didn't know what the x is. So that's what I would do. So it just depends on what's given to you. In this case, we already know because that was the first step, finding x, y, and r. We're plugging into that. So that's the reason why I chose it. So I said, might as well, right? Now, square goes on the outside of my parentheses here. Because when I'm squaring a fraction, I square the numerator and I square the denominator. So bring down my minus sign, parentheses, sine. What did we say sine was? -4 or 5. And that's squared, so on the outside. So again, when I square a fraction, I have this in parentheses because I square everything in it. So if I'm squaring a 3, I get 9 over, and I square the 5, which is 25. So that's 9 over 25 minus. Now, when I'm squaring the top over here, that's -4 times -4, right? If I square a negative, it will become positive. So 4 squared is? Very good. Over 5 squared?
25.
Yep. And now from here, can I just do the math? Yes, because they're already common denominator, aren't they? They already have common denominator, so I could just combine. And we come up with -7 over.
But that's, oh, never mind.
That one's just for the cosine value. The cosine double angle. Yes? Maybe? Yeah? Okay. So the last one we have to do is a tangent, right? Tangent's not going to be so bad because what does tangent represent? Y over x. Do we know the y? Do we know the x? So it's not that bad. So it's 2 tangent theta over 1, is it minus or plus here? Minus tangent squared theta, right? And this is from either the notes or the reference sheet. And so on this, we know x and y. So I'm going to just plug it in. And this 2 out front, that's a whole 2, isn't it? It's a whole 2 and nothing but the 2. So help me. Okay, anyway. I tried.
I'll turn it
Tangent is y over x. My y value was? -4. My x is? And that's the top, isn't it? Yeah? Okay. And the bottom is going to be 1 minus tangent, which is my -4 over 3, close square. No, I'm going to show you how to do it by hand because
their addition, are they positive now?
yeah, we're going to. So don't jump to anything yet. Now, the reason why I'm not saying yes, jump to the calculator is because you're going to end up with problems that you can't put in the calculator because there's a radical in there. the calculator doesn't like radicals, it will give you a decimal for it. So I'm going to show you how to do this. So let's start with the top. So multiply the top. On top, I get 2 times negative 4 gives me, very good, over 1 times 3. Now, on the bottom. So this is going to be slightly different. Slightly different, and I'm going to show you how to clean this up before I get too far into it. So I'm going to start by squaring first. Start with the square first. So negative 4 squared is 16 over 3 squared? 9, right? And because that's positive now, right? That's positive, so I have a minus sign here, right? Because I'm not changing the sign, but watch here. Here is the different thing. See that 1? 9 over 9.
Dang.
Why are we using 9 over 9?
Because that's still 1.
Common denominator is still 1. There it is, right?
Oh my god.
Wow. That just happened.
Where's the 9? Where'd you get
See,
the
okay,
9?
now,
3 squared.
yeah, that's the 3 on this bottom, right?
Yeah.
Right? That's that 9, right? That's that 9, right? What's 9 divided by 9? 1. Why do I want 9 on the bottom over here?
Oh, because
Common denominator. So, let's, okay, think about it now. If this 9 over here, if that was a 13, what would I change my 1 to? 13 over 13, right? Because 13 divided by 13 is 1, and that's this. 9 over 9 is also 1, which is this. Because I want to have common denominator, right? Just make it.
So you just change this whatever, but it has to match the.
It's the same value, right? It's the same value. It's still 1. It just looks different.
Oh, it's still 1. Right.
It's still 1. There we go. See? All right. So now on top I get negative 8 over 3 divided by, now the bottom. What am I going to get on the bottom? 7 over 9. But wait, there's more. Someone tell me what's wrong here. Fraction over fraction, right? Fraction over fraction. So that means I'm going to multiply by the... There we go. So I get negative 8 over 3 times the reciprocal. What's the reciprocal going to be? Negative 9 over 7. So with the negative, just make sure it's somewhere out front there, because I'm multiplying this fraction times this fraction. So a negative times a negative gives me a... So we're going to end up with a positive anyway, right? So I'm just trying to make my life a little bit easier. So 8 times 9 is 72, and 3 times 7 is 21. 21. Can I reduce that? Okay, what does it reduce to? 24 over 7. It reduces by a factor of 3. So we get a positive 24 over 7 for my answer for my tangent of 2 theta.
Oh my god, you said that was going to be easy.
X, Y, and R. It's just some steps. As long as you don't actually have to do all the identities. Hey, look, no, seriously. If you want to look at the notes, go look in the book. Look at the notes for this one. They are different because they don't ask you to do X, Y, and R. They're asking you to use different identities. I don't. Every unit that we have, I throw out most of the notes by using things that we already know, which are X, Y, and R. Every single time. And so why should we teach it differently to do the same thing? Use what you know. That's what I'm saying. Okay? All right, so I'm going to pause right here, and you guys are going to start, and you guys are going to do number 11 on the homework first. 11.
What if I want to do one of the other numbers?
All right, we're doing example 2 now. 2 is different.
Different.
It is different because it gives you something different. This time, it's giving me the double angle. That's not X, Y, and R. Double angle is not X, Y, and R. Single angle is X, Y, and R. Double angle is not. So I need to try and solve for x, y, and r. I want one variable. I want to plug this in somewhere where I only have one variable. This is where the cosine thing comes into play. I only want to solve for one of them. So what I'm going to do is I'm going to use the formula specific for this. I don't want to use the first one. Because this one has an x and a y, isn't it? I'm going to use the second one. It only has x's, right? It only has x's and no y's. So I'm going to solve for the x in this case.
So do you not need the y?
I do need the y, just not yet. Because we're going to have to solve for y also. But solving for y using a double angle sucks. You want to use single angles. You want to get your x, y, and r, and just go from there. So I'll show you the steps to actually get to this. So I'm going to use the second formula. So it's going to say cosine 2 theta is equal to 2 cosine squared theta minus 1. Again, I don't like double angles. I'm going to replace my double angle. What can I replace my double angle in my formula with? 4 over 5. Because that's what it's equal to, right? It's equal to 4 over 5 because that's what this says here. My cosine of my double angle is equal to 4 over 5. So I could replace cosine double angle with 4 over 5, and that's going to be equal to 2 cosine squared theta minus 1. Now, by plugging that in, I have now removed my double angles. All I have is single angles. Now all I have to do is get that single angle by itself. Add 1. Let's start with adding 1, right? All right, and I'm going to do some voodoo magic over here. Plus 5 over 5. Why am I using 5 over 5? I don't know.
Dude, I couldn't tell you, man.
Oh my goodness.
What's it for? Dark magic.
Yeah, dark magic. So common denominator is going to be 5, right? So 5 over 5 is still the 1. I'm still going to add 1, but it just looks funny. And so what do we get when we add those together now? 9 over 5 is equal to 2 cosine squared theta, right? What is that 2 doing to my cosine?
Multiplying.
How do you undo a multiply?
Divide.
Ooh, can I get a witness? Ha! No, guess not. Okay, I tried. All right, so I'm dividing both sides by 2. But watch this, watch this. I'm dividing by 2 over 1, aren't I? Is that still 2? And I got a fraction over here. Do I want to divide that by 2? No. I want to multiply that one by...
Steps. Yeah, calm down.
You lost me.
Okay, so watch this.
Well, I mean, you really didn't, but like.
If you would take 9 over 5, if we divide that by 2, what do we end up with there? Say fraction over fraction. And if there's a fraction over fraction, you're going to multiply by the reciprocal anyway, right? So, you know what? Just saving you some work, right? You don't have to go through and try to make it complicated. You know that dividing by 2 is the same as multiplying by 1/2. And that's what we're doing right there. Simon. Now, the left side of this. The left side of this. No, not going to cancel. What do we get? We get 9 over 10. Very good. 9 over 10 is equal to cosine squared theta.
Wait, so that's what I was saying. The big 2's cancel out. Or no? What happened to
What
the-
2's?
Those
The
two.
two-
Oh, right here on the right-hand side?
Yeah.
Yeah, right-hand side, those cancel. Yeah, I'm sorry, you got me there. So those go away. So now I'm going to go to another page over here because I don't want to cram my work into a small spot. So I'm going to say 9 over 10 is equal to cosine squared theta. So now, I gotta get rid of that square. How do I undo a square? Square root. I square root both sides, but if I square root, what can I not forget? Plus or minus. So now, watch this. Watch. Oh, okay. I'm looking for names.
If they're not here, then just keep them.
Keep them?
Yeah, it's just until they come by.
Oh, well, I don't want to keep it. I would just like, I'm more of a recycling person.
No, don't. They
Why?
need it.
Why? They don't need it. If they're not here, how would they need it?
They're gonna need it just for this one teacher, whoever it is, but you know.
Whoever, I don't know who it is.
Me neither.
I don't know who that is.
I'm delivering the papers. I'm telling you.
Hey, no, it's on you. So you gotta bring it back. When they decide to show up, you're gonna have to come back.
How am I gonna know they're back?
I don't know either, right?
Hold on to it.
Just hold on to it until they do come to your class. They always
What
show
if they
up.
never show up? Then what am I gonna do with this paper? What if they miss out on this?
Just keep. I mean, it's not gonna be until like February 8th.
February 8th. Hey, Edgar, what's good, man? Okay, all right. I'll see you.
Yeah.
All right, you guys.
Leave it in the door like an eviction notice.
Okay. Not everyone knows what eviction notices look like. Okay.
I do. I see somebody had one. Not mine. Like somebody else. That's
Okay.
scandalous. Why would they put their business out like that?
Okay. Anyway, you ready? Okay. If you notice, this was a fraction, right? And I square rooted, but then I separated. This is one of the properties of mathematics that I could do. So if I have a fraction, I'm taking the square root. I could actually do the square root of the top divided by the square root of the bottom, and it's going to be the same. I want you to make sure whenever you do this step, you're doing the same thing. Because the top, what is square root of 9? 3. And so we know it's going to be a plus or minus 3 over radical 10.
But you can't have a
But wait. No, it's less. It's a lot less. We're done. We're kind of done. What does cosine represent? X over r. So my x value is, it's going to be a plus or minus 3, right? I'm going to go back to the front page to explain this one. Y value is, I don't know yet, but r value is rad 10. That's all I had to do. All I had to do is actually get to this point right here where it's cosine of my angle. Because we know cosine is always x over r, so I know my x value, I know my r value. Can we find the y value? Yes, we can find the y value, can't we? How would we find the y value? Pythagorean Theorem. But before I do that, I'm going to go back to the beginning of the problem and look to see, is this going to be a positive or a negative? So, take your finger, put it on 90. Put it on 90, and then trace over to 180. Your finger on 90 and trace over to 180. What quadrant is that? Very good, quadrant 2. And what do we know about the x value in quadrant 2? Very good. So this one's going to give me a negative. So right here, this comes out to be a negative 3.
How do we know to go to what quadrant or to go to 90? And then,
See this right here?
yeah.
Right here, what I underlined right there?
Yeah.
So this says, put your finger on 90 and trace it over to 180. So you're following your finger from 90 to 180, and all that is quadrant 2, isn't it? And that's why we did that. So we say this is quadrant 2, and x value in quadrant 2 is always going to be negative. That's where we get that from. And that's why I did all that.
Will it ever go from like 180 to 90?
No, it won't go backwards. It can go from 180 to like 270 though.
That would be quadrant 3.
Yeah, that would have been quadrant 3.
Quadrant 3 negative.
Both are negatives. So we got that. Now let's take a look. So we're still missing, what are we missing here? Because I asked. All right, you ready? So we're going to plug it into the Pythagorean Theorem. And negative 3 squared plus y squared equals, that's going to give me square root of 10 squared. Now,
Wait, I thought this square was gone now.
huh?
Oh, wait, never mind.
Yeah. So right here, where you guys are talking about rationalizing, we can't have it. You'll see why it really doesn't matter yet.
Oh, that's what.
Why is it not going to matter?
Because it's just 10.
It's just going to give me 10, right? So you don't have to go through and do more work. You just know x, y, and r. That's what you need, right?
Yeah.
So negative 3 squared, that if you notice the negative is inside the parentheses.
Where you? Oh.
So negative 3 squared is going to be a positive 9 plus y squared equals, now when I square a square root of 10, that gives me just, very good, so 10, so minus 9 to both sides. Y squared is equal to plus or minus, I'm sorry, too soon.
Dang.
Y squared is equal to 1, right?
Yeah.
So y equals plus or minus square root of 1. Well, what is the square root of 1?
1.
It's just 1, isn't it? But, so, plus or minus 1. Where did my finger go? That was quadrant what? It's quadrant 2. What do we know about the y value in quadrant 2?
Positive.
It's positive, so this is going to be a positive 1. Yeah? So, this one right here starts off different because it's a double angle that they give you. That's probably going to be one of the biggest issues that you guys have when you're doing these homework. You have to look closely. If it says cosine of 2 theta is equal to something, that is the double angle. That is not x, y, and r. If it says cosine of just theta, the single angle, that one is x, y, and r. So I believe the notes on this one specifically said, find the 6 trig functions. It's not too bad, right? For my 6 trig functions, you only need to know
3 numbers.
x, y, and r, right? That's all you need. You could actually plug these in, and guess what? X, y, and r is on your reference sheet where to plug it in at. So I'm not going to diminish your intelligence by doing it for you. It's like reading something for you because I know you could read.
Wait.
So any questions over this one right here? I'm going to leave off on this. No? No questions? Are we good? Okay. Make sure you guys all like, share, and subscribe. Hit that notification button and buy stuff from my merch store. And just so you know, all proceeds of stuff from my merch store goes into the sock fund for Pacho. Get new socks.